Hi there, and welcome to my channel. In this question, we are given that for time t greater than or equal to 0, a particle moves in the xy plane with the position x of t and y of t, which is not given explicitly, and the velocity vector, which is given explicitly, which is t minus 1 times e to the power t squared and sine of t to the power 1.25. And we are also given the position of the particle at time equals 0, which is -2 and 5. And the first question is to find the speed of the particle at time t equals 1.2 and find the acceleration vector of the particle also at time t equals 1.2. So let's draw a little picture here, which is x and y plane. This is x, this is y, and then this is the position of the particle at time t. This is the velocity along the x-axis. This is the velocity along the y-axis. And so the speed is this, the length of this vector here, which is the hypotenuse of the Vx and Vy triangle, the triangle which has them as two other sides. And so the speed is equal to, by Pythagorean theorem, is equal to the square root of Vx squared plus Vy squared. And so in our case, V is equal to the vector t minus 1 e to the power t squared and sine t to the power 1.25. And so then we need to find speed at time t equals 1.2, which is equal to the square root of t minus 1 e to the power t squared plus sine of t to the power 1.25, and again this is squared as well, and this has to be evaluated at t equals 1.2. And so we need to find this value using our calculators. And then to find the acceleration, let's recall that acceleration at time t is equal to the derivative of the velocity with respect to time at time t. And so a along the x-axis, acceleration along the x-axis is the derivative of the velocity along the x-axis with respect to time, and a sub y of t equals the velocity of along the y-axis at time t. So then ax at the point 1.2 is equal to the derivative with respect to time in our specific case, t minus 1 e to the power t squared, evaluated at t equals 1.2, and then acceleration along the y-axis at 1.2 is equal to the derivative with respect to time of sine of t to the power 1.25, evaluated at t equals 1.2. And so we need to pull out our calculators and calculate these three values. And let's do that. And so let's calculate the speed and the acceleration. And for that, let's go here, the square root of the value in parentheses 1.2, plugging in 1.2 instead of t, minus 1, close parentheses, times e to the power 1.2 squared all of this, close parentheses, all of this squared, plus sine of, in parentheses, 1.2 to the power 1.25. We have an extra close parenthesis here, squared, and let's calculate that. So the answer is 1.271, 1.271, that's the speed. And to calculate the acceleration, let's first calculate the acceleration along the x-axis, derivative with respect to x, doesn't matter, x or t, we are using x here, of the function x minus 1 close parentheses times e to the power x squared at the point 1.2, and the value is 6.247, and then acceleration along the y-axis, the derivative, again with respect to x, of the function sine of x to the power 1.25, and evaluated at the point 1.2. And so the value is 0.405. And so these are the three values we have. And so as we just calculated, the speed is 1.271. The acceleration along the x-axis is 6.247. And then acceleration along the y-axis is 0.405. And so to write down this, we write down acceleration as 6.247 as a vector and 0.405. This is a vector of acceleration. Let's move on to part B. In this question, we need to find the total distance traveled by the particle over the time interval from 0 to 1.2. And total distance traveled by the particle between the time t0 and t1 is equal to the integral of speed as a function of time dt. And in our case, again, we had the expression for speed in the previous question, and the integral is from 0 to 1.2. So in our case, distance is equal to the integral from 0 to 1.2 of the square root of t minus 1 e to the power t squared plus sine of t to the power 1.25, and this is squared, and then the square root of this dt. So let's pull out our calculators and calculate this distance. And so let's calculate the total distance. And for that, we go to the integral, definite integral from 0 to 1.2 of the square root of the expression x minus 1, close parentheses, e to the power x squared close parentheses squared plus sine of x to the power 1.25 close parentheses, and this is squared as well, and this integral with respect to x. And so let's calculate it, and the answer is 1.010. 1.010. And so as we just calculated, the total distance is equal to 1.010. Let's move on to question C. In this question, we need to find the coordinates of the point at which the particle is farthest to the left for time greater than or equal to 0, and explain why there is no point at which the particle is farthest to the right for time greater than or equal to 0. And so first, let's recall that x prime of t is equal to the velocity at time t. And so to find the local minimum or local maximum of x, we need to equal the derivative. So look at all such t where v of t is equal to 0. So in our case, this is t minus 1 times e to the power t squared equal to 0. And e to the power t squared is always positive. So it's only when t minus 1 is equal to 0 that this is true. It can be 0. So solving, it's equal t equals 1. And so let's see whether this is a local minimum or a maximum. And we know that this is a local minimum because v of t is less than 0 for t less than 1, and v sub x of t is greater than 0 for all t is greater than 1. And so using a little graph here, if this is x, then the particle first between time t0, t equals 0, and t equals 1 moves to the left. Then at time t equals 1, it stops, and then it starts moving to the right. So this point at time t equals 1 is the farthest to the left. So let's calculate that point. And by the fundamental theorem of calculus, x at time 1 minus x at time 0 is equal to the integral from 0 to 1 of v sub x of t dt. And for our case, then x of 1 is equal to -2. This is position at time 0 plus integral from 0 to 1 of 1 t minus 1 e to the power t squared dt. And so we will need the calculator to calculate that. And similarly, y at time 1 minus y at time 0 equals integral from 0 to 1 of sine t to the power 1.25 dt, which is y at time 1 is equal to 5 plus that integral from 0 to 1 sine t 1.25 dt. And this is the general form here is integral from 0 to 1 v sub y of t dt. So again, let's pull out our calculators here to calculate that. We won't need that. And so before we go to the calculators, let's look at the position to the right. And so the velocity of time t is equal to t minus 1 e to the power t squared. And note that this velocity is greater than 2 minus 1, plugging in t equals to e to the power 2 squared, which is equal to e to the power 4 of first power 4, all t greater than 2. So the velocity of this particle, this particle moves to the right with the velocity at least v of x is at least e to the power 4. It's actually much greater than that. So there will never be a point such that the particle will just stop and not go further to the right. So there is no such point at which the particle is farthest to the right. Let's go back to our integrals here to find the position of the particle when it's farthest to the left and pull out our calculators and calculate those two values. And so let's calculate the position of the particle. For the x coordinate is equal to -2 plus the integral, definite integral from 0 to 1 of the velocity, which is in parentheses x minus 1 times e to the power x squared dx. And so the value is -2.604, -2.604. And the y coordinate is 5 plus definite integral from 0 to 1 of the velocity along the y-axis, which is sine of x to the power 1.5. And integral with respect to dx. And the value is 5.410. So 5.410. And so as we just calculated, the x position is -2.604, and the y position is 5.410. So the position of the particle when it's farthest to the left is -2.604 and 5.410. Thank you for watching. If you liked this video, please don't forget to click the like button. Also, leave me your comment in the space below and subscribe to my channel where you can find more solutions to the Calculus AB and Calculus BC problems. And I will see you in the next video.